Welcome to Rationals for Pre-Calculus of Math 11. Today we're going to take a look at multiplying and dividing rational expressions, which is section 7.2. We can use similar techniques as multiplying and dividing rational numbers when we do the same thing to rational expressions. So when we just multiply fractions or divide fractions, we can do the exact same thing here. You may have to factor before simplifying the rational expressions. Really, the factoring is just so that we can look for things to cancel off. You got to recall that we still need to state any non-permissible values, I should read values there, in the expression. So let's start with simplifying each expression and state any non-permissible values. So we saw last section 7.1 about non-permissible values. Basically, just take the denominators, make them equal 0, see what happens. What values do those occur for? I'm going to do that kind of quickly here. Maybe I'll try and always do it in red. Non-permissible values here would be x can't equal 0 for this one. Let's then maybe take this 6x, 5y, those are all multiplied by 7 and 3x squared. We have some canceling that occurs. The 3 and the 6 reduce to give me 2. One of the x's from the bottom will cancel with the x up top, and what we're left with is basically 2 times 5 is 10y over 7x. So fairly straightforward. We're just canceling like we normally cancel. In this case, make sure we have it all factored, make sure we have the pieces, the non-permissible values stated. So why don't you try B here, hit pause now and give B a crack. So non-permissible values would be x can't equal -1, that's from the 2x plus 1, and we also get that x can't equal 0, that's from the over 3x. Let's maybe just try some canceling straight off here. 3x and 3x, that cancels very nicely. The x plus 1 and the x plus 1, that cancels quite nicely. So what we're left with up top is a 7. We still have that factor x plus 3, and in the denominator we have a 2. So I think fairly straightforward. We're just looking for groups of things to cancel. We can't cancel off pieces. We have to cancel off the entire binomial or trinomial. So one of the problems though that we run into is when we divide, so when dividing by a rational expression, we need to consider non-permissible values of both the numerator and denominator. So when we typically talk about non-permissible values, we are only looking at the denominator. Now the problem here is that when we're dividing by a fraction, if you think about regular old fractions, what we do is we take the reciprocal of that fraction, we flip it, and we multiply by that. So suddenly the numerator becomes the denominator. So we have to consider those non-permissible values. So having to consider the non-permissible values of the numerator is because when we divide by a rational expression, we multiply by its reciprocal. And this, in effect, makes the numerator a denominator as well. So let me do a first step here of just rewriting this question. 2x, x plus 3 over 14x minus 5. Because I am dividing by x over 2x plus 10, let me invert and multiply. So 2x minus 10 becomes the numerator and x becomes the denominator. So let's talk about some non-permissible values. We have x minus 5 can't equal 0. That's from our first fraction. The original denominator of 2x minus 10 can't equal 0. And the new denominator in that divisor, x can't equal 0. And we end up with x can't equal 5. 2x can't equal 10, which is, oh, look, x can't equal 5 at the same time. And x can't equal 0. So we have an x can't equal 5 and we have an x can't equal 0. From here, let's go ahead and make sure we factor everything. So the first fraction is okay, first rational expression. We're multiplying by this one. We can factor out a 2 out of the numerator. leaving us with a 2 times x minus 5 over x. We get some cancellation here. The x minus 5s cancel. an x and an x cancel. And 2 times 2 is 4 over 14 leaves us with 7 and that 2 still. So what we end up with, we have a 2 up top and an x plus 3, and in the denominator we have a 7. So there it is. There's a simplified expression where we're dividing, and we took care of any non-permissible values. So let's take a look at a couple more examples. Maybe I'll do one more, and then you can try the second one. Let's go through this a little bit quicker, maybe. Let's factor everything. If I factor out a 3a, I'm left with a minus 3. In the denominator, I have a minus 6 and a plus 2. We're dividing by, so let me invert that and say we're multiplying it. A squared minus 4 factors into a minus 2a plus 2. 2a minus 6, we can factor out a 2, leaving me with 2 times a minus 3. So let's talk about non-permissible values here. A minus 6 can't equal 0, which means a can't equal 6. From the first fraction, a plus 2 can't equal 0, so a can't equal negative 2. We have a plus 2 can't equal 0 from the second fraction. We already dealt with that. We have a minus 2 can't equal 0, so a can't equal positive 2. And a minus 3 can't equal 0, which means a can't equal 3. So we have 4 non-permissible values here. Let's take a look at some cancellation. A minus 3 and a minus 3 cancel. The a plus 2 and a plus 2 cancel. Number-wise, 3 and 2 doesn't reduce. A is not going to reduce. So that looks about it. Let's change that to black. We have 3a, a minus 2 left in the numerator, and we have a 2 and an a minus 6 in the denominator. So you start to see how all that factoring stuff we've done, we have to keep doing here when we start talking about these rational expressions. This looks like a little bit more of a complex one. Certainly multiplying here. Why don't you hit pause and see if you can simplify that. Let's start with some factoring. That factors into 2x minus 3 and x minus 2 in the numerator. In the denominator, we can pull out a 2, leaving me with x squared minus 9, which we will have to factor again. The other fraction that we're multiplying, or a rational expression I should say, is 2x plus 1 x minus 3. And if we factor out a 6, I'm left with x minus 2. I see some cancellation already. Why don't I just get rid of the x minus 2's because I can, leaving me with 2x minus 3. X plus 3, x minus 3 from the difference of squares. 2x plus 1, x minus 3 over 6. And I just remember I forgot my non-permissible values. We could go with x squared minus 9 can't equal 0, which is x squared cannot equal 9. X cannot equal positive or negative 3. So that's from the first fraction. The second fraction, second rational expression, x minus 2 can't equal 0, so x can't equal 2. So those would be the 3 restrictions we'd have here. What other canceling can occur? The x minus 3's can certainly cancel. 2x minus 3 in the numerator, I don't see that anywhere else. 2 in the denominator. You know what? There's not too much other cancellation that's going to go on here. We're just going to leave it maybe nicely factored. 2x minus 3 times 2x plus 1. 12 times x plus 3. So multiplying and dividing rational expressions is just the same as multiplying or dividing fractions. You just have to reduce and invert and multiply where appropriate. This ends the notes for multiplying and dividing rational expressions section 7.2.